What if a star could explode not once, but twice? What if that double explosion created some of the heaviest elements in the universe and sent ripples through space-time itself? Today, we're talking about a possible brand new cosmic phenomenon that astronomers are calling a superkilonova. And if it's real, it could completely change how we understand the death of massive stars. For decades, scientists thought they had stellar explosions figured out. There are supernovae, which happen when massive stars run out of fuel and collapse, blasting their outer layers into space. These explosions are incredibly bright and help spread elements like carbon, oxygen, and iron across the universe. Then there are kilonovae, which are even more extreme but far rarer. Kilonovae occur when two neutron stars, the ultra-dense remnants of dead stars, spiral together and collide. These events release enormous energy, produce gravitational waves, and create heavy elements like gold, platinum, and uranium. In fact, much of the gold on Earth may have been forged in kilonovae billions of years ago. Until now, astronomers believed supernovae and kilonovae were completely separate events. But a strange observation has scientists wondering if nature sometimes combines them into one dramatic, two-stage explosion. In a distant galaxy about 1.8 billion light-years away, researchers detected something unusual. First, gravitational wave observatories picked up faint ripples in spacetime, the kind usually produced when neutron stars merge. That alone would suggest a normal kilonova. But then telescopes noticed something strange. Along with the expected glow from a kilonova, there was an extra burst of light that didn't quite fit the pattern. Instead of fading smoothly, the object brightened again days later. Even more puzzling, this second burst showed signs of hydrogen, something you'd normally associate with a supernova, not a kilonova. That's when scientists began asking a bold question. What if this wasn't one explosion, but two? According to the superkilonova idea, the story might go something like this. A massive star reaches the end of its life and explodes as a supernova. Instead of leaving behind a single neutron star, the violent collapse causes the core to split or fragment in a strange way, ultimately forming two neutron star remnants in a tight system. Over a short period of time, possibly hours or days, those two neutron stars spiral toward each other. When they finally collide, they trigger a second explosion, a kilonova. The result is a rare double blast, first a supernova, then a kilonova, producing both traditional starlight and gravitational waves. This would explain the odd observations: hydrogen from the supernova, heavy element signatures from the kilonova, and gravitational waves from the neutron star merger. It's a cosmic 1-2 punch that astronomers have never clearly seen before. If confirmed, superkilonovae could answer some major mysteries. They might explain how certain heavy elements formed so early in the universe. They could help scientists better understand how neutron stars are born and how extreme gravity behaves. And they might reveal entirely new ways stars can die. But here's the important part. This discovery is not confirmed yet. Some scientists urge caution. Gravitational wave detectors are incredibly sensitive, and sometimes signals can be caused by noise, like vibrations near the instruments. Others point out that while the light and gravitational waves appeared close together, it's still difficult to prove they came from the exact same event. Even the researchers involved stress that this is a candidate superkilonova, not definitive proof. To be certain, astronomers need to detect more events like this, preferably closer ones that can be studied in greater detail. The good news is that the future looks promising. New and more powerful observatories are coming online, designed to scan the sky constantly for cosmic explosions. With better data, scientists may soon catch more of these rare double blasts in the act. If superkilonovae are real, they represent a completely new chapter in astrophysics, a reminder that the universe still has surprises waiting, even in places we thought we understood. Somewhere out there, stars may be dying in ways we've only just begun to imagine, exploding, collapsing, and colliding in a spectacular final act that shapes the very elements we're made of.